Okay, so in this video, I just want to talk a little bit about derivatives of general exponential and logarithmic functions. And unlike a lot of the rules, you don't have to memorize these ones because you can derive them quickly using the chain rule. So this is if y is log b of x, then the derivative dy dx is 1 over x ln of b. That's the rule. And if h of x is log b of g of x, so some type of chain rule thing here, then you see that you get g prime over g times log of b. So it looks almost exactly like the rule for natural logarithms. You just have this log of b sitting there. And I can show you how to derive that. So I'll give you an example of how you might use this. And I'm also going to just show you that you don't need to memorize this rule. You can derive it pretty quickly. So let's say y is log 3 of some g of x, like x squared plus 7. And so what does that mean? You can translate that into 3 to the y equals x squared plus 7. You're raising both sides of that equation to 3 to the something. Okay, and so from that now you can apply the natural logarithm to both sides. So I'm just applying ln to both sides, and maybe I'll do that in a different color. Okay, so that's applying a continuous function to both sides, so that's going to keep the equation true. And now you can use property of logarithms to simplify that. You get y times natural log of 3 equals natural log of x squared plus 7. And now you just take the derivative. So we're gonna take the derivative of both sides. We're gonna apply d dx to both sides. Maybe I should do that in a different color. D dx, left-hand side, the right-hand side. And what you get then is what? You're going to get dy dx times the natural log of 3, that's just a constant, equals, and now the derivative of the logarithm, well, we know that it's u prime over u, so that's going to be 2x over x squared plus 7. And now you see that that's exactly what we had in that formula, because you have dy dx. If you divide both sides by natural log of 3, then you get 2x over x squared plus 7 times the natural log of 3. Okay, so that's the g prime of x over g of x times natural log of your b. That is exactly what this formula said here. Okay, and now we'll do another example. If y equals b to the x, then dy dx is b to the x times natural log of b. So I'll show you how to derive that. So maybe I'll slide over here and do an example. Let's say y equals, I don't know, 7 to the x. Then if you take natural log of both sides, you get natural log of y equals natural log of 7x. But what's that? That you can bring the x out front then. So I'll simplify that using logarithm rules. We have natural log of y equals x times ln of 7, which is just a constant, right? So when we take the derivative of this function now, we get, well, the chain rule says this is going to be y prime over y, or the natural logarithm rule says that's y prime over y on the left. And then it's going to be, well, natural log of 7 times x, what's the derivative of that? That's just natural log of 7. Okay, so it looks like y prime, or dy dx, is, I'll write down both notations for that. Y prime, or dy dx, is just natural log of 7 times y. But what was y? Y was 7 to the x. So this is natural log of 7 times 7 to the x. Okay, and that's exactly what the law says. It's, if you're taking the derivative of y equals b to the x, then the derivative is going to be b to the x times natural log of b. Okay, thank you for your time. Hopefully that kind of clears things up. This isn't something you have to memorize. You can always derive it using this trick where you take natural log of both sides and then apply the chain rule.